looking at the second problem, so the second problem states, it says, find the domain of the function and write it in interval notation. So first of all, interval notation, that's where we either use the parentheses or the brackets, depending on whether it's included or not included. In order for the function to be a function, that means that it has to be, the function has to exist in every single domain, right? So the fact that it's a fraction means that the bottom cannot be equal to 0. And if we look at a little bit further at the denominator, we have a square root. Well, in order for the square root to be a function, the stuff inside it needs to be greater than or equal to 0, right? So in other words, it has to be 0 or positive. But the fact that it's in a fraction in the denominator, it cannot be 0. So what we're looking for strictly is for the stuff inside the square root to be greater than 0. So that automatically tells me that I'm going to be using parentheses. And so the only thing I have to worry about is the bottom being positive or greater than 0, because at the moment the numerator, if the numerator is 0, then that's okay, I get 0. But the bottom cannot be 0 because that'll be undefined. And so what we really have to do is we need to focus on 2x minus 3 being greater than 0, and we're going to solve for x. So we solve for x by adding 3 to both sides, and then we're going to divide by 2, and we get x greater than 3/2. So x greater than 3/2 written in interval notation is 3/2 not included all the way to positive infinity. So what that's saying is that any value that you choose, as long as it's bigger than 3/2, then we're going to be positive inside my square root. A quick way that we can check whether that is true or not. So at 3/2, I know my function is 0. I know my function is undefined, or the denominator or inside the square root is 0. So if I choose any number to the left of 3/2, for example, if I choose 0, right? So if I plug in 0, that goes away. I get -3, which means that the whole inside the square root is negative, which we don't want. We want it to be positive. Same thing goes to the right. So any number to the right, maybe I choose 10 because that's pretty easy to check. We plug it in for x, and we're trying to figure out, am I going to end up being positive or might end up being negative? So 2 times 10 is 20, minus 3 is 17. In other words, I am positive, which is exactly what I wanted, hence my interval notation. And that's as much as we need to do to show the work for that answer. Moving on to the next one. So we have a piecewise function, and they asking us to find two different outputs, f of -2 and f of 11. Well, the very first thing we got to figure out, okay, if I'm going to work on f of -2, I got to figure out, okay, -2 is part of which domain? So I got to figure out in which domain does the x value -2 fall in. Well, -2 is definitely less than 2. So that's telling me that in order for me to find my value of -2, I got to use this expression. So we have 3x squared. Instead of writing x, we're going to replace it with -2 and then plus 16. Now we have to be careful because the -2 it represents x. So we're going to put it inside parentheses because when we square it, that means we're going to end up with a positive 4. And then once we multiply by 3, we get 12 plus 16. And so I end up with f of -2 equals 28. So the second one, we got to figure out, okay, what is f of 11? So same thing. I have an x value. I have an input of 11. 11, although it looks like it might be part of this bottom one, it does not include 11. And so since it does not include 11, I'm not going to use that one, but instead I'm going to use this middle one, because that one, that inequality has that or equals to, which means it is part of that domain. And so I'm going to go ahead and use that second expression, and I'm going to plug in 11. And for x, I have 11 minus 2, which simplifies to the square root of 9. And the square root of 9 gives me two answers. I have a positive and a -3.